Okay, well, welcome back. Let's see. This is, I believe we're in week 9 now, so way past the halfway point. Don't even think about quitting. This is homework 28 of, I believe there's 44. So we're way downstream here. We're on page 418. This is problem 19, which is a sister to problem 17. And over the next couple of videos, we're going to focus a little bit on graphing trig functions. In this case, we're going to take on 4 cotangent x. I've spent a couple minutes beforehand here getting things set up so I can run through this fairly quickly with you. 4 cotangent x, we're not going to worry too much about the 4. The 4 is just a scaling function. It's just going to pull the sine, the cosine, which have amplitudes of 1 on their own, up to 4. It's going to multiply every y value by 4. And we're going to just take care of that with the scaling here. So let's do this. And the way I'm going to do it is I'm going to draw a sine function. I'm going to draw a cosine function. From that, we're going to reason out what a tangent is, and from that we're going to reason out what the reciprocal of the tangent of the cotangent is. So I'm right up here with sine. I've got scale pi over 2, pi, 3 pi over 2, 2 pi, and I'm going to kind of slowly walk through this. And it all starts by remembering that the sine of 0 is 0. So sine of x starts right there. Right, and you can see that over here in the unit circle. Here's a theta, which is pretty close to 0, and there's the sine, a pretty small number. And as this ray moves up and we let theta get larger and larger, that y value increases until we get to pi over 2, because at pi over 2, sine reaches its maximum value of 1. And then it starts to decrease, right? There's a value for a theta greater than 90 degrees, and there's the y, and then here's an even bigger theta, and there's the y. So it decreases back to 0 at pi. So we can draw that like this. Here goes the sine, starts at 0, finds its maximum, goes back to 0, and then it does essentially the same thing. Goes back to actually a minimum of -1 at 3 pi over 2. You can see it right there. There's 3 pi over 2, and there's the sine. And back to 0 at pi over 2. That's the sine. That's the sine. Let me see if I can just kind of make use of this to draw the cosine now. The cosine near 0, it's this length along the x-axis, is about 1. And it starts to decrease as theta increases until it gets to pi over 2, in which case it is equal to 0. So here comes the cosine, heads down, pretty awful job there. Here comes the cosine, shoots down to 0. It will go find the value -1 here. It'll go back to 0. And it'll finish out its cycle over here at 2 pi with a value of 1. So we've treated both sine and cosine. And as I said, if you want to plot sine and cosine of 4x, all you have to do is call this value right here 4. We'll call this value right across here -4. And I'm not going to plot it. I'm not going to worry about that anymore. So, how about the tangent of x? What do we do now? Well, we've got to remember for the tangent of x that the tangent of x is just the ratio of the sine of x to the cosine of x. So let's just think about what's happening between 0 and 2 pi. Let's think of tangent for a moment as this fraction with the sine on the top and the cosine on the bottom. So from 0 to 2 pi, as x moves from 0 to 2 pi, the top is increasing, the bottom is decreasing, and so the tangent is going to increase. It's going to start at 0, since sine of 0 is 0, so is the tangent of 0, and it's going to increase. How much is it going to increase? Well, let's go all the way to the end of this pi over 2, and as you can see that as x approaches pi over 2, cosine of x is approaching 0, right? And so as the denominator here gets smaller and smaller and smaller and smaller, this is getting bigger and bigger and effectively without bound. So in other words, cosine has a vertical asymptote here, and it looks like this. It's like that, yeah? And what happens on the other side of cosine? Well, on the other side of cosine, vertical asymptote, it's going to come up from here until we get back to pi. And let's ask what's special about, what, if anything, is special about pi? Well, at pi, here's the angle pi right here. And notice that the sine of pi is 0. So cosine is going to come up from here and go through 0, and then repeat what we had over here. At 3 pi over 2, the cosine is equal to 0, and so the tangent then shoots up again as it did over here. Same thing over here. We've got, I'm going to draw this and erase it, because it's going to interfere with my cotangent. There's another cycle of the tangent right there. So let me lose that for a minute, and let's go deal now with cotangent. So a couple ways to deal with cotangent. You can just think of it as the the reciprocal of the tangent, and in that case, first of all, note in this region 0 to pi over 2 that the tangent is everywhere positive, so the cotangent is going to be everywhere positive. But the tangent's 0 here and infinite here, so can you see that it's just going to go like this and swing right through the 0, and again, the tangent is 0 when when its argument is pi. And so the cotangent, which is the inverse, is going to go approach infinity like this. And we're going to get these things. Let me just kind of talk you through that. Well, I did such a good job drawing those before that. Let me just talk you through this in another way. Let's look at the cotangent from this perspective. It's a little bit more difficult perhaps, because in this case, the cotangent is, well, I guess not. In this case, the cosine is decreasing, which is going to drive the cotangent to decrease. And likewise, the sine is increasing in the denominator. So the top of this fraction is decreasing, the bottom is increasing. The cotangent from 0 to pi over 2 is going to decrease. And where does it start? Where does it start? The cosine, in this case, is near 1. The sine on the bottom is near 0. So the cotangent is going to be a big number around x equals 0. So in short, here are 3 little cycles of the cotangent. And off to the next problem.